A cup of coffee with temperature 130 degrees Fahrenheit is placed in a freezer with temperature 0 degrees Fahrenheit. After 15 minutes, the temperature of the coffee is 39 degrees Fahrenheit. Use Newton's law of cooling to find the coffee's temperature after 20 minutes. So to approach this problem, the first thing you need to know is the formula for Newton's law of cooling. The formula is capital T of T equals T naught plus T1 minus T naught times e to the negative kt. Okay, now that's a lot of t's, so we have to make sure we understand what all of the t's represent. The T of T is going to be your final temperature, or the temperature after T minutes. So in this situation, they told us that after 15 minutes, the temperature of the coffee is going to be 39 degrees Fahrenheit. So in this situation, I can say that the final temp of my coffee was 39 degrees Fahrenheit. The T sub zeros represent the surrounding, or the room that the temperature was placed in. So in this situation, we placed our coffee in a freezer, and our freezer was 0 degrees Fahrenheit. So anywhere we see the T with the subscript 0, that is going to represent the temperature of the surroundings, and we can substitute the 0 into that equation. The T sub 1 represents the original temperature of the body. Okay, so originally when we poured our cup of coffee, it was 130 degrees Fahrenheit. So we can substitute that 130 in for the T sub 1. E is your natural number, and you're going to use your calculator for your natural number unless you really feel like taking decimals and raising them to really high powers. The K, we do not know. The K is unknown in this situation, and we're going to have to find that out. And for this first part of the problem, we know that the coffee was down to 39 degrees after 15 minutes. So the lowercase t is going to represent how many minutes elapsed, and that will be 15. So you're going to end up having to do this problem twice. You're going to have to first go through and solve this exponential equation for k. Then you get to repeat the problem and find out what the final temperature is after 20 minutes. Okay, so using the order of operations to simplify the right-hand side of the equation, we would first simplify what's in the parentheses. 130 minus 0 is 130. If you wanted to, you could subtract 0 from each side, but I think we all know that subtracting 0 is not very interesting, and you get back your 39. Okay, next you need to isolate your exponential. The exponential is currently being multiplied by 130, so the opposite of multiplication is division. So we will have to divide each side of the equation by 130. I'm going to leave it as a fraction just so that I don't have to deal with the giant decimal at this point. So I'm just going to leave that fraction there. And then that will have my exponential isolated. Okay, now here's where most students say, I have no idea what I'm doing, because you have this exponential equation, it's raised to this power, you are trying to find the k that's up in the power, and you don't know what to do. So what you have to remember is that the inverse operation of an exponential is a logarithm. So the way I'm going to undo the e raised to a power is to take the natural log of both sides of the equation. And the natural log of an exponential base e are inverses of each other, and they end up reducing away. And so you would just be left with negative 15k on the right-hand side. So to figure out what the k value is, you would need to take each side of the equation and divide it by negative 15. and that's going to give you your K. So in this problem, K equals whatever this decimal is going to be. Now you're going to have to type that in your calculator. So in my calculator, I am going to hit my natural log button. I'm going to put the 39 divided by 130 in parentheses. You can hit enter if you want and get a nasty decimal. And then I'm going to divide that nasty decimal by negative 15. And it'll tell me my K value is 0.08026. And you can go further. There's more decimals, but I'm just going to go to that place right there. Now this is great. You haven't answered the question. What was the question again? The question was, what's the temperature of the coffee going to be after 20 minutes? So that means you're going to have to start back with your original Newton's law of cooling formula, and you're going to have to use that K value that you just found to find that question. So let's start on a fresh page for that. Okay, so to do this, we're going to have to go back to the original Newton's formula, which is your final temperature T is equal to the temperature of the room plus the temperature of the coffee minus the temperature of the room equal to e to the negative kt, where t is the number of minutes there. So we're looking for our final temperature, so that's going to be unknown. We know that the freezer was 0 degrees and that the coffee started at 130 degrees. We just found our K value in the last problem, which ended up being 0.8026. And we've left the coffee in the freezer for 20 minutes. So if you're pretty good at using your calculator, you can put this problem in just like that without doing any simplification, and I'm going to show you how to do that. Okay, so on this problem, I can go to my calculator and I can type in 0 plus parentheses 130 minus 0, close my parentheses. I can put in my exponential and my negative 0.08026 times 20. Now, if you're using an older version of the calculator where you don't get that beautiful math type, you will need to put in parentheses around that exponent. So you'll need a parenthesis on each side of the exponent. If you're using a calculator like mine where you can see where the exponent is nice and clear, you don't need the parentheses, but the older ones you do. You can just hit enter and you get the answer of 26.11. So after 20 minutes, the coffee will be down to 26 degrees.